to all. My name is Gautami. My topic name is mathematical analysis for the non-recursive algorithm. Non-recursive means something is not repeated. That is called as a non-recursive. We can see the general plan for the analysis of the non-recursive algorithm is basically there are 5 steps in this analysis for the non-recursive algorithm. The very first step is determine the number of parameters to be considered, that is based on the input size, and then identify the basic operation, algorithm basic operation, and check whether the number of times the basic operation repeated, executed or repeated depends on the input size, and if basic operation to be executed depends on the some other condition, it is we have to obtain the worst, best and average case separately. After do this one, we can sum up the total number of the basic operation executed, and then we have to use the standard formula and then obtain the order of the growth. This is the general plan for the analyzing the non-recursive algorithm or time efficiency for this non-recursive algorithm. The basic formula for this one is summation of I from lower to upper. Execution time is 1. Then formula like this: upper minus lower plus 1, where lower less than or equal to u. And then consider the one algorithm and analysis the time efficiency for this algorithm. The algorithm name is maximum number of n elements. We have to consider the array and it having a number of elements. A of array equals to 20, A of 1 equals to 40, A of 2 equals to 25, A of 3 equals to 55, A of 4 equals to 30, and then I ranges from the 1 to n minus 1, because here the elements are n, then n minus 1 comparisons in the algorithm, so we have to consider the I ranges from 1 to 4. Now see the algorithm for the maximum n elements. Algorithm maximum a comma n. A means array consists of n elements and n means number of elements in the array, and position points to the contains the position of the largest element, and position points to initially 0, and then I ranges from the 1 to n minus 1. If the A of I greater than A of position, if the element is greater than the position, then position equals to element, like this. Here end the end for and return the position for the maximum element present in the array. And then now we have to analyze the time efficiency for this algorithm. We analysis through the 5 steps. The basic step is first step is parameter to be considered, that is here we given the n input size, so n is the parameter. Then basic operation is A of I greater than A of position, and total number of basic operation executed can be calculated. Number of times comparison is executed. How can we have to calculate this one? If the algorithm makes I comparison each value of the loop, which is repeated for each value of the loop variable I within the bounds 1 to n minus 1. And now calculate to the formula. We can see the previously one formula, like that only follow. Here only one for loop, so f of n equals to I ranges from 1 to n minus 1. The execution time is 1, and then n minus 1 minus 1 plus 1, then minus 1 plus 1 cancel, we can get the n minus 1. N minus 1 equals to n, so f of n equals to n. This f of n will be represent using the arbitrary notation, so time complexity is given by f of n equals to theta of n. Theta of n is average case. We can get this time efficiency for this algorithm. Now you can see the another algorithm. If the basic operation executed, basic operation depends upon the other condition, we have to go the 3 cases, right? The worst, best average case. we can take that example and we can analyze that like problem. The problem name is the algorithm name is element uniqueness problem. Let us design the algorithm and check whether the given array having a uniqueness elements or not. Here given the elements like these are the unique elements present in the array, these are elements not unique in the array, like so on. Now see the algorithm. Algorithm is, this is the algorithm. Algorithm unique element a comma n. Input is a number of elements in the array. A means array consists of n elements. Here output we can get if it returns 0 if the elements are not unique, return 1 if elements are unique. For I ranges from 0 to n minus 2. For j ranges from I plus 1 to n minus 1. If a of I equals to a of j, if the element, if the a of 0 element is equals to a of 1 elements, it means the elements are not unique in the array, so it returns a 0. If it is not unique, if it is unique in the array, it returns the 1. Here end for the this, close the for loop, close the for loop for this one, and this one is the end, this end for this, for the this outer loop closed for this one. And now analysis the time efficiency for this algorithm. We can see the previous one. There also parameters to be n, like here also parameter consideration n into n, because we can give the input size is n, and basic operation statement is here the a of I equals to a of j, and there we can see the a of I greater than a of position, because we have to place the maximum n element in the array. Here we have to check the unique element present in the array or not. So our basic operation is a of I equals to a of j. If it is not unique, it returns 0. This is the basic operation in this algorithm. Because step 3 is it is not depend only the n, it also depend how many times the element will be repeated in the array. If it is not repeated many times in the array, the number of comparisons are more. So it is not only depend on the n, it depends on the position of the repeated elements present in the array. So we have to calculate the best, worst and average case. Worst case, here in this algorithm we have it having the two for loops. One is inner for loop, another is the outer for loop. Inner for loop ranges from 0 to n minus 2, and outer loop ranges from I plus 1 to n minus 1. The execution time is 1. First we have to solve the outer for loop. Here we have to solve this using the formula like upper minus lower plus 1. Here n minus 1 minus I plus 1 minus 1. We can after solve this one, n minus 1 minus I minus 1 plus 1, here both are cancelled. We can get the n minus 1 minus I. We have to take the common n minus 1, and then inner for loop I ranges from 0 to n minus 2, 1, and then this outer loop will be solved by using a formula n minus 2 and n minus 2 plus 1 and divided by 2. Then finally analysis of n solved by the mathematical way, we can get the finally n minus 1 n by 2 and the t equals to n square minus 1 divided by 2, it equals to n square, f of n equals to n square, and then finally f of n equals to f of n belongs to big O of n square. We can analyze in the best case the elements. Best case efficiency, best case occurs when the array elements are stored in a uniqueness way. So it is observed in the best case, basic operation will be executed only once, so the time complexity will be f of n belongs to omega of 1.